We are yet to bring in the structures on it. Now the question is the following. Can you extend addition, multiplication and order relation to the enlarged class? So this, let us call this for the time being R minus. And then correspondingly you can see that corresponding to every rational number here, you have a minus of that here. Therefore you have now, this is your Q minus, and then also minus. So you write the following. Later you see that after fixing the status of 0, etc., one can show that Q is essentially the set of all psi such that psi belonging to Q plus union 0 union minus psi then you have Z, that is the set of all integers, set of all psi belonging to n, union, the new entity that we have introduced, union, what we call minus psi for so these are called the set of integers, these are called the set of rationals, these are called the set of numbers. Okay, fine. So this is just a formal thing that you do. And we just named it and fine. Okay. So we will show that 0 is qualified to be here, 0 is also qualified to be here. Some flavor, right? And so also if psi is in n, there is the corresponding element as the qualification to be included in this class. Now this is what you get. So we have got now the real number system, the rational numbers system, and the set of integers. Okay. How do you extend addition, multiplication, and order relation? These are the three things that we have to work with. The whole R. Okay, so let us do this one by one. Okay. So first we work with the order. Order relation. Order relation is, these are things associated with it, less than, and then you have equal to, then greater than. These three things are. We will define one, the other things will come from it. Okay. So we define. First we define what is called the absolute value. Okay. So for R plus, define mod psi as For psi equal to 0, for psi equal to 0, that is the new one that we have defined. Define mod psi equal to 0. So, then for psi belonging to R minus, let me write minus psi. How does this element come? This element comes from an element in R plus. So only the existence of an element in R plus that brings an element minus psi in R minus. What we have said is that for any psi in R plus, there is a corresponding element minus psi in R minus. And for this element, define modulus of minus psi equal to psi. So that is the definition of the modulus function. So the modulus is essentially a map from R to, so modulus is a map from R plus, from R to zero. This is what you call the positive value of the number. Okay. So that's about it. Now we make use of this to define the remaining things. Now we are in a position to introduce order. Let so we have to define this in different ways in different places. Okay. So what do you mean by, we say psi is greater than eta if the following are. There are a lot of things that you have to look at. Okay. Whenever psi belongs to this, already we have this notion on R. So we have R plus only. That we are not tampering with. We are going to use that to define the order structure on R minus. That's something that you should understand. See, in mathematics, you do a step, you will have to justify it. So when psi is greater than eta has a very definite meaning when both psi and eta are in R plus. So now we are interested in what happens when psi belongs to R minus, eta belongs to R minus, and what you should have. See, this is the thing. See, if psi belongs to, eta belongs to R, we say that psi is greater than eta. What happens? Its reflection is mod psi here, its reflection is mod eta here. So our common sense experience says that psi is greater than eta if mod eta is greater than mod psi. So that is the, so under this condition, this is, so that means I will just quickly check it with a value. Once and suppose you take psi as -5 and eta as -10. You know that -5 is greater than -10. What are the corresponding positive things? You have 5, take the absolute value, this is 5, and this is 10. So you say that -5 is greater than -10 whenever 10 is greater than 5. Okay, right? That's what we write here. Right? So that's the condition. So you can write this equivalently as mod psi less than mod eta. This is an equation. Okay, that's the position that you have. Now that takes care of all psi and eta on in R minus. Okay. Already when both psi and eta are in R plus, everything is fine. Now you have various situations. One of them may be 0 because you have to talk about what happens when psi is 0. So we have 2 equal to 0. 0 is greater than, so eta belonging to R minus. So whenever psi is equal to 0 and eta belongs to R minus, you have psi greater than eta. So these are all or what is the third condition? When you have psi belonging to R plus, eta equal to 0. There again, you see, psi is greater than eta. Or what else you have? You have one of them in R plus and one of them in R minus. Okay, so you have psi belonging to R plus, eta belonging to now the fifth one is of course our the one that we have already resolved, or for completeness I write this: psi belongs to R plus, eta belongs to R plus, and you have psi greater than. So now all possible choice of psi and eta has been covered. Now this is the meaning of the greater than. Now one can prove all the consequences related to the order here. Okay. So what are the consequences? So let me just take this out. This out, because I don't want this part. This part I don't want to erase at the moment because I want to complete that picture. So what I have now is something on this side. And psi here. That's that. Minus psi. Okay. So one can prove, I am not going to prove this, but I will just list out all the sort of things that we want to assert. Things like, see the given belonging to R, this is what one can do. Either psi is equal to eta or psi is greater than eta or eta is greater than. See, one of the three properties, one of the three relations alone hold. Okay, you cannot have simultaneously both the things happening. Okay, right? So given psi and eta, now this is a very standard property that you are familiar with. Now the next thing is that we give a different symbol connecting greater than or less than, because we have already introduced greater than and less than. So we have psi is greater than or equal to eta. Now, yeah, what do you mean by this? This is a two statements fused together. So it says psi is greater than eta or equal to eta. That's the meaning. Okay. So this implies, in fact, if and only if eta is less than or equal to psi. So less than we have introduced. I mean, similarly, you can write down what less than is all about. Okay. Because greater than, whenever you say psi is greater than eta, is equivalent to eta is less than psi. Only when the equal to comes, it is different. Okay. So you have this relation. Now this is again to be proved from the fundamentals and from the definition. So you have psi greater than 0, then psi belongs to R plus, or psi is a positive number. Earlier I was talking about R plus. So they are the collection of all positive reals. Similarly, psi less than 0, this means psi belongs to R minus, or you call psi a negative These are by way of definition, actually. All this needs an elaborate proof. Starting from the definition, one has to prove it. Now we also one gets the following: mod psi, no matter whether psi is positive or psi is negative, mod psi is always greater than or equal to 0. Now we have the transitivity property extended. Yeah, you know that there is transitivity property on R plus. So you can extend it here. So what you have? You have psi greater than 0, psi greater than eta, and eta greater than zeta implies psi is greater than zeta. This is the transitivity property. And equivalently, you also have this property that psi less than eta, eta less than zeta implies psi is less than. So these two properties are straight away there. Then you have psi, if you bring in equal to also, so psi less than or equal to eta, eta less than zeta implies, this means what? Even if you have psi equal to eta and eta is less than zeta, then you have psi less than zeta. This is strict inequality that you have. Or psi less than eta and eta is less than or equal to zeta. This also implies okay. So these are the properties that you can prove.